All right, so I'm going to do a video on the distance formula and the midpoint formula for using the coordinate plane. And what I'm going to do here is I'm going to try to do this, explaining a few different things. So here I have the point A, and the point A is at 2, 5. That's my x value, and that's my y value. And I have another point here at 9, 1. This is point B, and this is 9, 1. Now, if I want to know the distance between A and B, what I would do is I wouldn't actually use an eraser or a ruler, but to measure it. But what I would do is I would draw a straight line between the two, and it would look something like this. This is the distance. Oh, sorry. This is the distance between A and B. All right. Now, when we're talking about distances, we are talking about the distance between the 2 points. So the distance formula basically says distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And that looks like a pretty awful formula, but it's not actually all that bad. And I'm going to explain why in a minute. But before we actually get into the formula, I want to show you something. If I were to go straight down from A and then straight over, I would be making a right angle triangle. Now, this distance here is, let's see, 1, 2, 3, 4. There's 4 units. And this distance here is 1, 2, 3, 4, 5, 6, 7. It's 7 units. Now, if you recall the Pythagorean theorem, so I'm going to do the Pythagorean theorem. The Pythagorean theorem says c squared equals a squared plus b squared, assuming that c is your hypotenuse. And in this case, c is the length AB. So I'd say c squared equals 4 squared plus 7 squared. C squared equals 16 plus 49. C squared equals, let's be 50, it'll be 65. So c equals, it's actually plus or minus the square root of 65, but because it's a distance, we ignore the negative value. And we'll just say c equals the square root of 65, and that's your answer. Now, the reason why I bring this up is because if this is my x1, and this is my y1, and this is my x2, and this is my y2, take a look what the distance formula actually says. It says x2, which is 9, minus x1, which is 2, quantity squared. Well, when we do that, we're going to get 7. And then y2, which is 1, minus y1, which is 5, quantity squared. And so when we do this, we get 7 squared plus a negative 4 squared. Well, negative 4 squared is going to end up being a positive 16. So I get the square root of 49 plus 16, which is the square root of 65. Now, what I really want you to understand is the Pythagorean theorem and the distance formula are essentially the same exact thing. X2 minus x1 is this distance here. I counted 1, 2, 3, 4, 5, 6, 7, but if I took 9 minus 2, I get 7. y2 minus y1 is essentially this distance here. Once again, I counted 1, 2, 3, 4, but if I take 5, subtract 1, I get 4. And so there is a very, very, very not a strong correlation. They are the same. That's exactly all there is to it. They are exactly the same. Now, I'm going to, let's see, erase the link. Good. All right, so now I'm going to go and I'm going to do another one. Let's say I want to find the distance from A down to C. Well, you don't actually have to use the distance formula. You could just count because it's a vertical line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. If I were to use the distance formula, I'd get the square root of, well, my x2, this is 2, 5, and this is 2, negative 5. My x2 minus my x1 would be that, plus 5 minus a negative 5 squared, and I'd get the distance equals 0 plus 5 minus the negative 5 becomes 10. 10 squared. Distance equals the square root of 100. And the distance equals 10. Now, obviously, that's very, very silly, and you should never do that because it's a waste of time. My point is, if you want, you can just count vertical. If you had another point and it was horizontal, let's call this point F. Difference between F and B would just be 1 unit. All right. So that's the distance formula. I'll do one more. I'll do one more distance formula for you. And I'm going to do, let's do D to C. Now, D is at the point -1, 3. C is at the point 2, -5. This is my x1 and my y1. It's the first point. X2 and y2, that's my second point. Sometimes it actually even helps to say point 1, point 2, x, y. Sometimes I have students do this and it actually helps them out a little bit. You can say -1, 3, 2, and -5. Now remember, the distance formula says square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And then we go, distance equals, let's say x2 would be 2 minus a -1. You have to be careful with your parentheses. Plus y2 would be this one here. This would be a -5 minus 3 quantity squared. I get distance equals 2 minus a -1 is a +3. -5 plus a -3 becomes a -8. So I get distance equals the square root of 9 plus 64. Distance equals the square root of 73. And it's a little bit unfortunate because I was hoping to have to simplify radicals, but that doesn't work. And I'm going to check very quickly. If I go down and over and I make my Pythagorean theorem or my right angle triangle, I can say 1, 2, 3, 4, 5, 6, 7, 8. So CD squared equals 8 squared plus 1, 2, 3, 3 squared. CD squared equals 64 plus 9. CD squared equals 73. Find the square root of both. I can ignore the plus or minus because it has to be a positive distance, and I get that. So now, your question should be, why on earth would I ever use the distance formula if I don't have to? And the reason why is this. If you have 4.2, sorry, let me redo that. If I had something like, let's see, 1.4 and 0.2, so that's 1.4, 0.2, and then I had -0.8 comma 2.2. You could use the Pythagorean theorem, I suppose. It still works, right? But it's a little bit trickier, and so now I could do my distance formula. And I'd say x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And I get the square root of, and my x2 is 1.4 minus a -0.8 quantity squared plus y2, which is 0.2 minus 2.2 quantity squared. And then I end up with, let's see, this is going to be 2.2 squared. Do you see how I messed up my parentheses there? Plus -2 squared. And let's see, pardon me. 2.2, I should know what this is. 2.2 squared equals 4.84. Going back. Uh-oh. Oh, I think I just lost it. 4.84 plus 4. And then I do the square root of that. And you get about 2.97. You could round that to 3, I guess, if you want to. But that's it. That's the idea behind the distance formula. And it's not too bad. Like I said, you should learn the distance formula, but if you ever get into problems, draw a picture, find the Pythagorean theorem, you'll be in good shape.